Hey guys, this is Mr. Grice for Algebra Unit 9 Review B. Remember to show all your work. Okay, question 1 and 2 says graph two relations on the graph below. The first must be a function. The second cannot be a function, okay? So once again, this first one can be a function. The second one can what? Cannot be a function. Okay, so you are not allowed to graph any of the following: linear, exponential, quadratic, square roots, or absolute value. You need to be creative, okay? So whether you're going to start drawing some squiggly things like that, that's fine, even like that. Ooh, I don't know if that works. Maybe not that one, okay? But you need to be creative, all right? And for ones that are not a function, remember, it cannot pass the vertical line test. So that passes the vertical line test where something like this would not. Okay, so that's up to you. You guys draw it and check. Okay, you can come see Ms. Carranza or myself. Next one says graph a function with the given description, type, and domain range. So the first one is exponential. Our domain is all real numbers, and that y has to be greater than -3. So that means that my graph can get close to -3, it just can't touch it, okay? So you can do this one of two ways. Well, you can do it actually tons of different ways, but remember that it can't touch -3. It gets really close, but then it's going to shoot right up. So this would be exponential growth. Now, if you wanted to do exponential decay, that means that it's going to be going down, and then the same thing. It gets really close to it, but it doesn't touch -3. Okay? And the graphs could be changed horizontally if you want to. All right, number 4. We have a quadratic. Our domain is all real numbers, and our range is less than 3. Less than or equal to 3, sorry. So at 3, it doesn't matter where you put it. I'm just going to put it right there. I need everything to be less than that. Okay, so if it's less than that, can my graph go up? No. Okay, so you pick the point where you want it, and then we know how to do the pattern. Okay? So that's one example of what yours could look like. Okay? But if you didn't graph it there, you could have graphed yours right there, or all the way over here, or all the way over there. Okay? Doesn't matter where you graphed it, as long as it's less than or equal to 3. All right, perform the indicated operation for the given functions. So we've got our 3 functions, the f of x, g of x, and h of x. Our first one is asking us to subtract g of x minus, h of x. All right, so our g of x is 3x squared plus 7x minus 8, and we are subtracting that from x squared minus 2x plus 1. Okay, so there's the first thing. All I did was write everything down. But now we're going to be subtracting, which means I have to distribute a -1 to everything in the back. So I'm going to rewrite the yellow because nothing changes. And then the only thing that changes in the back are going to be my signs. So before that was a positive x, guess what? Now it's a negative x squared. It was a negative, blah, 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 blah. It was subtracting the 2x, and now I'm adding the 2x. It was plus 1, now it's minus 1. Okay, let's combine our like terms. We get 2x squared. What's next? Plus 9x. And the last one, minus 9. So 2x squared plus 9x minus 9. Okay, 6. F of x times g of x. So let's go ahead and write what that would look like. It would look like negative 6x minus 4 times 3x squared plus 7x minus 8. So there are a lot of different ways that we can multiply this. When I'm multiplying anything more than binomials, I personally like to use the box method. So I'm going to put the negative 6x and the negative 4 down here, and then the 3x squared plus 7x minus 8. So you can multiply it however you want to. I want you to pause the video, see how you do, and combine your like terms. And let's see if we get the same answer. Good luck. Okay, you should have gotten negative 18x cubed minus 54x squared plus 20x plus 32. Okay, and if you have any questions on how I got that, you can look to see my work. All right, number 7. Now, we had a lot of questions on number 7 in class. So just remember, g of negative 3, that's what you're plugging in. Into the equation, we're plugging in that negative 3, okay? And whether you plug that all into your calculator at once or you show the work, I'm going to go through and show the work. So we always do exponents first. So negative 3 times negative 3, or negative 3 squared, is 9. Okay, next step would be to multiply. 3 times 9 is 27. 7 times negative 3 is negative 21 minus 8. So 27 minus 21 is 6, and 6 minus 8 is negative 2. And that's our final answer. All right, in 8, we take negative 4, and then we're going to times that by h of x. So all I did was take h of x, which was right up there. That's what it told us to. And we're going to distribute, okay? So you take that negative 4 and you multiply it by everything. Why don't you guys go ahead and try it? Okay, so you should have gotten negative 4x squared plus 8x minus 4. Okay, let's go ahead and flip it over. So graph each function and evaluate the function for the given value. Then give its domain and range. So let's go ahead and graph this. First thing I notice, reflection, and it's a square root. So that means my graph's going to be going down. And our initial point is negative 4, positive 6. Okay, so at negative 4, positive 6, it's where we start. And then I go down 1, right 1, down 1, right 3. And then that's reflected. And there's our graph. So f of negative 4, at negative 4, what's it equal? 6. Now be careful about your domain, because it's not all real numbers. If it's all real numbers, my graph would be right over here, but it's not. So x has to be greater or equal to everything left of this right here. okay, or everything right. So x is greater or equal to -4. And remember, there's a reflection for the y-axis, so it's everything below, so y is less than or equal to 6. And remember, for the square root, we get those numbers from our initial point. Okay? All right, 10. The first thing I notice about 10 is that it is absolute value. Is there a reflection? No. Okay. Our vertex for this is 5. Good. -2. I almost made a mistake. So at 5, -2, that's where I'm going to start. And then I go up 1, right 1, up 1, right 1, up 1, right 1. There we go. Beautiful. Find the value of f of -4. Well, f of -4 is all the way here. I don't know what it is. Is that a typo? Guys, it's not a typo. Okay. You can continue the pattern until we get the number that we need. Okay, so I just continued that graph. Okay, and at f of -4, you should get the point. What? So up 1 over and up 1 over. What point is that? Good. That point is 7. Our domain for an absolute is all real numbers. And what about our range? It's not all real numbers because everything has to be higher than that point. So what is it? Y is greater than or equal to -2. All right, graph the following piecewise functions for the given domain values, then identify its domain and range. All right, so our first graph is going to be in blue. It's a linear. Our slope is 1/3, and then our y-intercept is -2. Okay? And then our limit is at 3. So I'm going to draw my line, and I want everything to the left of this. So at 0, -2, I'm going to go up 1 over 3, and since it's less than, that's going to be a close point. And I'm going to continue my line in the other direction. Okay, but I want to make sure that I don't fill it in because it is open. Okay, so there's our first graph. Now let's work on our second one. Our second one's a quadratic. Is there a reflection? Nope. And then what's our vertex? 4, 1. Good. And then same thing. At 3, I want everything that's to the right, greater. So at 4, 1, that's where I make my first point. And then I go 1 point to the left and it's closed. And then I go up 1, right 1, up 3, right 1. And there we go. Okay, so what's the domain? Well, are there any breaks left to right? No. The only one that we have is right at 3, and since one's open and one's closed, that means it's all real numbers. And then what about our range? What about our y values? Well, our linear graph is going forever down, and our quadratic is going forever up. So that means that there's no break. So we have all real numbers. All right, number 12. Number 12, I'm going to let you guys do this on your own. So make sure that you're writing down, is there a reflection? What's the vertex or the initial point? Okay. And then we can talk about the domain and range together. So go ahead and pause the video and good luck. Okay, so first thing we're going to talk about is the domain. That's what you guys should have gotten. I left my my limit right there, the 3, so you guys can kind of see that I went to the left less for the quadratic and it's open, and to the right greater than or equal to for our square root, and it was reflected. So our domain left to right, there are no breaks. Okay, so that is all real numbers. Now, let's take a look at the y. Is there a break? Well, yeah, I want you to take a look. I know it's very, very small. Is there anything in between there minus those points, but one's at -1 and the other's at -2? There's a break there. It's the first time we've seen something like that. So we know that first off, y for the quadratic is greater than or equal to -1, and y is also less than or equal to -2. I know that's kind of crazy. It's the first time that that's ever come up, but it's there, so we got to make sure that we write that down. All right, last one. Write the equation that correctly represents the function. All right, well, let's look at 13. 13's just a quadratic, so that's good. What's the vertex? Vertex is 1, 2, so it's -2, 1, 2, 3, 4, up 4. So remember that that's going to help us when we fill this in. Okay, is there a reflection? Yeah, so the reflection, remember that tells us that it's negative. And we always start that at subtraction, but it's a -2, so that's really going to be +2. And then what type of 4 is that, positive or negative? Yeah, that's positive, so +4. Okay? All right. Next one. Next one, we have 2 graphs, okay? So I'm going to put our first one in blue and then our second one in red. So when we're talking about the blue, that's absolute value. Okay? It's reflected. What else do we know? What's our vertex? It's at -1, +4. And then what about the limit? Where does it stop? Okay, it stops at 0 and it's open and we go to the left. So that means it's less than or equal to 0. So the pink one is a square root. There's no reflection. Our initial point is 0, 1. Okay, and our limit is that x has to be greater than or equal to 0 because it's everything to the right of that. So I want to see if you guys can write both of those on your own. Pause the video, and then I'll have the answers up in just a sec. Good luck. Okay, and that's what you should have gotten. Now, if you need help with this or any other thing from Unit 9, make sure you ask because your test is, that's right, tomorrow. This is Mr. Grice signing off for Algebra Unit 9 Review B. Thanks for watching.